Bonsuelo, mathletes. It is a great day today. It is the first day we actually get to learn something. Okay, as an introduction today, I just want to give you some important definitions. It may not seem like it's that big of a deal right now, but these are things, the first set we're going to use every day, and the second set of definitions we're going to use pretty much every day. So let's get right to it. The first thing, what I want to talk about, first set of definitions, is what's an equation versus an expression. And eventually I'll tell you why you need to know these definitions. Okay, so first of all, let's say you came into class today, and as you walked in the door, I handed you a quiz. And you get to your desk, you look at the quiz, and there are no instructions. All there are two problems. The first problem says this, 2x plus 5x. The second problem says 2x plus 5x equals 14. Now, what if I had put instructions for each of those problems? What would be the instructions for the first problem? What would be the instructions for the second problem? And you can pretty much figure out, just by looking at the problem, what the instructions would be. Not absolutely perfectly that you'd be able to figure it out, but in general, you should be able to figure it out. Well, the first one would be solve. Sorry, that's wrong. It is not solve. The first one would be simplify. And the second would be solve. Okay, now why is that? Basically, because the second statement is a type of equation that the first one is not. Okay, the second statement, 2x plus 5x equals 14, is an equation. The first one, 2x plus 5x, is an expression. Or if I can put a little more simply, it's a non-equation. It's not an equation. Okay, now, how can you tell by looking at this whether something's an equation or not? Okay, most important thing being an equation, whether you can tell whether it's an equation, whether it's not an equation. Well, first of all, it's not the presence of an equal sign. Make sure you're very clear on that. This first problem, I'm just going to write something real quickly and then scribble it off, so you don't need to write this. What if on the first one I had written 2x plus 5x equals, and that was it? That's still not an equation. There's an equal sign, but it's not an equation. An equation is not something that has an equal sign, okay? It's a little bit more than that. Okay, what an equation is, and I'm going to put it kind of crudely, but is something that has stuff on both sides of the equal sign. So notice the first one, 2x plus 5x, it doesn't have an equal sign, but even if it had an equal sign, it wouldn't have stuff on both sides of the equal sign, so it's not an equation. The second one, 2x plus 5x equals 14, is an equation. Why? Because there's stuff on both sides of the equal sign. And quite frankly, it really is that simple, okay? But it's very important that you can look at something and know what's an equation and what's not, because you treat equations totally differently than you treat things that are not equations. Okay, that's the first set of definitions. Make sure you know it. If there's stuff on both sides, it's an equation. If there isn't stuff on both sides, then it's not an equation. It's good to know that it's an expression, but the main thing is that you know it's not an equation. Okay, that's the first set of definitions I want you to know. The second set of definitions is, what's a term versus what's a factor? Okay? All right. what's a term? A term is something that is added or subtracted. So, for instance, if you have x plus y minus z, all of these things are terms. Each one is a term. Okay, fine. That's what terms are. Second, then, what's a factor? A factor is something that is multiplied. Not multiplied or divided, but just multiplied. So, for example, if we have x times y times z, each of these things is a factor. Okay, so you should know what makes something. If you look at something, you should know that it's a term, or you should know whether it's a factor, whether it's something that's added or subtracted, or whether it's something that's multiplied. Now, what difference does it make whether you know this or not about terms versus factors? Okay, so the first thing, I'm going to tell you two things why it matters. The first thing is you distribute to terms, not to factors. Okay, so what do I mean by this? Okay, first of all, let's say we have two situations. The first one is 2 times the quantity AB, and the second one is 2 times the quantity A plus B. And I want you to rewrite each of these without parentheses. Fine, so what would the first one be? It'd be 2AB, and the second one would be 2A plus 2B. Okay, what did we do with the second one that we didn't do with the first one? We distributed the 2 to both the A and the B. Why? Because A and B are terms. Okay, why didn't we distribute to the A and the B in the first one? Because A and B are factors. Now, I know this is going to seem kind of weird, but could have I done this? Instead of writing 2AB, could I write A 2B? Now, you don't really want to do that, but I'm just saying would at least be technically correct. Yeah. In other words, you can give the 2 to either the A or the B, but not both. Okay? Whereas that's in the first part, the first problem listed. The second one, you have to give the 2 to the A and the B. Why? Because you distribute to terms, not to factors. Okay, so let me just take a couple simple examples and show you like how this works. Okay, so let's say we have 1/2 10 times 4. And then the other example is 1/2 10 plus 4. Okay. Well, in the first one, yeah, okay, first of all, you'd probably multiply the 10 and the 4 and get 40, then multiply by 1/2 and get 20. Fine, I understand that's what you do, and that's perfectly good. I'm just trying to illustrate something. Let's say you want to multiply the 1/2 first. Would you give the 1/2 to the 10? Would you give it to the 4? Or would you give it to both of them? Well, you don't give it to both of them because the 10 and the 4 are factors. Okay? So you can give the 1/2 to the 10 and call it 5 times 4, which is 20. Or you can give it to the 4 and say that's 10 times 2 is 20. I don't care. It doesn't. Either one's fine. You give the 1/2 to either the 10 and the 4 and not to both. Why don't you give it to both of them? Because 10 and 4 are factors. Whereas in the second one, you give, again, probably what you'd really do is add the 10 and the 4 and get 14, multiply by half and get 7. But if you're going to multiply by the half first, you would give the half to the 10 and the 4. You would distribute. Why? Because they're terms, and you always distribute to terms, not to factors. So you take the half and you'd multiply it by the 10, then you take the half and multiply it by the 4. And again, really what you do is probably go 10 plus 4 is 14 times the half is 7. But if you're going to multiply by the half first, you get 5 plus 2, which is 7. Okay? So again, what do? You distribute to terms, not to factors. So that's one reason why you want to know the difference between terms and factors. Okay, well, what's the second reason? Now, what I'm going to talk about here is not a rule in math. The distributive property, which I just talked about, that's a rule in math. Okay, you distribute to terms. This is what I'm going to tell you is just kind of a good thing to know. It's just a good thing to remember. It's about shortcuts in math. So not about technical rules, but about shortcuts. Okay? Basically what it is this. Shortcuts in math apply to factors. Okay, so the first thing I set up here, that you distribute to terms, here I'm saying shortcuts apply to factors. Okay, what do I mean by a shortcut? Okay, so for instance, let's take the square root of 9 plus 16. Okay, now, technically what you should do is add the 9 plus the 16, get the square root of 25, and then take the square root of 25, which is 5. Okay, fine. The question, though, is, may you just take the square root of the 9 and the square root of 16 individually and then add them? No, you can't. Why? Because that's a shortcut. Okay? And if ever you want to take a shortcut, look for a plus or minus sign. If you see a plus or minus sign, you can't do it. Okay? Because shortcuts only apply to factors. So what if you had the square root of 9 times 16? Okay, technically what you should do is multiply them and get the square root of 144, and then take the square root of 144, which is 12. Fine. But may you take the square root of the 9 and the 16 individually and then multiply? Yeah, you may. And it's going to be quicker. So if you take the square root of the 9, you get 3. You take the square root of the 16, you get 4. And then that's 12. Okay, what allows you to do this? The fact that there's no plus or minus. If you want to take a shortcut, look for a plus or minus. If you see it, you can't take the shortcut. That is a very good thing to remember. Just a couple other examples that I want to give you to kind of illustrate this idea. What if you have 10 times... Sorry, let's do the other possibility first. Let's take the addition first. What if you have 10 plus 7x divided by 5? May you cancel the 5 and the 10? No, you can't. Why? Because there's a plus sign. Again, I want to take a shortcut. I want to cancel the 5 and the 10. Can I do it? Well, I look for a plus sign. There's a plus sign, so I can't do it. So that's it. That's as simple as it gets. But what if you had 10 times 7x divided by 5? May I cancel the 5 and the 10? Well, is there a plus sign anywhere there? No. So yeah, you can cancel the 5 and the 10. So cancel the 5 and the 10, and you get 2 times 7x is 14x. Okay? So, two things I want you to get out of today. What's the difference between an equation and an expression? An equation has stuff on both sides. What's a term versus what's a factor? A term are things that are added or subtracted. A factor is a thing that is multiplied. And what does it matter? You may distribute to terms, not to factors. That's the first thing I told you right here. And the next thing is any shortcut you ever want to take in math, it only can work for factors. So if you see a plus or minus, you can't take a shortcut. Well, I hope that has made your day enlightening. I welcome you all to class. I hope you have a great year this year. I hope we learn a lot of math and enjoy doing it together. And I will see you next time, where what we're going to start doing is, first of all, talking about expressions, things that are not equations. And then after a few days of that, we'll talk about equations, things that have stuff on both sides. Bye-bye, everybody. Have a good day.